Right now, a single vehicle holds the record for the highest thrust and largest payload capacity ever flight tested. SpaceX's Starship represents the current peak of what a modern Superheavy launch system can achieve. But China's state-backed space program is developing its own Superheavy system to challenge that dominance. It is an enormous concept vehicle known as the Long March 9. Estimates place Starship at 123 meters tall, while Long March 9 could reach 150 meters, like adding extra floors to a massive skyscraper. Its payload fairing is staggering. At 16 meters wide and nearly 50 meters long, Starship's upper section could theoretically fit inside. Adding meters and mass requires tremendous technical capability. But we have to ask if physical volume is actually the right metric for measuring off-world capability today, or if this massive design is optimizing for a space race that no longer exists. A 16 by 50 meter fairing solves a specific logistical problem. When you are building infrastructure in deep space, the raw physical volume of your payload matters just as much as its mass. This colossal volume allows engineers to launch entire space station modules in a single flight, avoiding complex orbital assembly. Manufacturing a rocket this large requires an equally massive industrial footprint. Reports indicate China is planning a dedicated production facility covering roughly 100,000 square meters. That structure reportedly includes a gateway reaching 85 meters high, simply to move the rocket sections outside. Aerospace engineering is rapidly looking more like industrial-scale architecture. The Long March 9 is expected to run on methalox fuel, a mix of methane and liquid oxygen. Methane burns cleanly, simplifying engine refurbishment, and it can eventually be manufactured directly on Mars using local resources. Between the massive fairing capacity and the dedicated industrial facilities, this vehicle proves China is looking far past low Earth orbit. They are establishing the heavy logistics needed for permanent off-world colonization. Extreme scale introduces extreme risk. The Long March 9 has unusual physical proportions, creating a top-heavy mass distribution that complicates both manufacturing and flight operations. Placing an exceptionally wide 16-meter fairing on top of a gigantic 90-meter single booster creates intense aerodynamic drag. Pushing that blunt shape through the dense lower atmosphere generates turbulent forces across the entire airframe. Traditionally, rockets solve efficiency problems through staging. By dropping heavy, empty fuel tanks as they climb, the remaining vehicle mass drops, allowing the smaller upper stages to accelerate into orbit with much less effort. The Long March 9 appears to rely heavily on that single, massive lower booster. Hauling that much dead weight high into the atmosphere sacrifices the performance advantages normally gained through early staging. Recent concept illustrations show Long March 9 upper stages equipped with aerodynamic flaps. This detail indicates that China's engineers recognize the limitations of discarding such massive hardware into the ocean. Flaps serve exactly one purpose in rocketry: aerodynamic control during atmospheric descent. China is actively studying pathways toward the reusability model proven by SpaceX. History shows that building a brand new, massive vehicle for every single launch creates a staggering cost burden. By exploring aerodynamic flaps, China is signaling a move toward reusability, proving that raw size alone cannot overcome the economic reality of expendable superheavy rockets. If height and width were the only metrics that mattered, Elon Musk and SpaceX could simply stretch Starship's dimensions to match or exceed 150 meters. SpaceX is not competing to build the tallest rocket. Their engineering efforts are entirely focused on rapid and complete reusability. That is their operational mode. True aerospace dominance requires treating launch vehicles like commercial airplanes, flying them repeatedly with minimal downtime between missions. Starship also utilizes a flexible upper stage architecture. Instead of relying on one massive fairing, one core vehicle design is adapted into specialized variants, including orbital tankers, lunar landers, and heavy cargo carriers. This creates an interconnected ecosystem rather than a single heavy payload delivery method. Competing against a network of specialized vehicles that support one another is far more complex than simply matching the lift capacity of a single rocket. The framework for off-world logistics has changed. The ultimate victor will not be the one with the highest payload capacity on paper, but the one with superior economic efficiency, launch cadence, and operational flexibility. Whether the Long March 9 eventually eclipses Starship in physical scale is secondary. This rivalry between two super-heavy platforms guarantees a decade of intense innovation, accelerating humanity's push to build permanent infrastructure across the solar system.